Hello, this is Yash Mehta again, and this is my second video explaining the code throughout the game. And I'll be starting off first at the way beginning. We do have comments on the top saying this is our final project, who was created by myself and my partner Josh. And it starts off basically declaring the first scene in the game, which when click the restart button, it is our title slide, and the creation of the button, which is the start button up here with the rectangle, the fill color, what it says, start, size, so on and so forth. And then the splash screen function saying that when the current scene is 1, it puts all this background here, it puts all the text that we desire, our button again, and then we have the start button function, all the simple things to make the first page described as the first page. So this is our current scene 1, and when we call it in our draw function at the end, the code will understand, it'll compile and understand that this is our current scene is equal to 1, else it'll go to current scene 2, which is our game. So essentially throughout the game we have declarations that we tried to make like efficient towards the game and use variables that made sense. So like dimensions we used as like what the actual squares look like, what the board looks like, the grid, so on and so forth. We have the time lapse, which is in the game when you combine the tiles, there's like a sudden like small delay that happens. So like quickly to show, like when I combine these numbers, there's a small like little halt there, and that's for the time lapse. So we're adding 12 to the time lapse because if we do a much bigger number, it'll either the number will become really big or it'll just take a very long time for the numbers to essentially appear on the screen, which we don't want to happen. So all in all, we just used the number scrubber and we found out that 12 ended up being the best. And then we obviously have the behind color so the background color, the squares itself, what color we wanted, the main screen featuring the whole board and grid, and then the number colors obviously, so we can set it apart because we need the numbers to appear on a certain background, on a certain main screen background, so on. Then we have the different things that we added throughout the game. So the score, it's 0 right now because we're not telling it to increment. We're going to do that later on in the code. Same thing with the temps in the right corner. The animation throughout the game, which allows it to move along the screen, and when the games are required, what happens at the ending of the game, like the try again that you saw in the other video, or when you hit 2048 or 2048, however you want to call it, it says that congratulations, you won. And then here in the grid size, it's basically telling the code or telling JavaScript that this is the size that we want it, and we want the squares to be a certain size too. So we set the board equal to 42, which doesn't fill the whole page, but it's perfect right in the center of the screen, and it's easy to see. Same with the square size. We don't want something too big. We want it to be able to work. And then the grid size, so that's the whole thing. We wanted to do it, so we took a width number and we subtracted that from the board to create an actual meaningful size. And then the tile size, obviously, same thing. We need to make it so that they all fit on the screen without causing any issues. Like if anything is combined, the tiles don't shift. So we need everything to stay in a one still motion, but only having the tiles with the numbers when they're colliding, as mentioned in this code here, with the tile contact. That's the only time where, one, the tiles move, the numbers will go up, the score will go up, and the attempts will go up because the game is constantly going through. And we have the empty positions function, which is allowing us to show that in small areas of the game, those that are not open, there's no numbers appearing there. The only time a number appears if like a box or a tile is moved to a certain side, and when you combine them, they only appear when the user touches a certain arrow key in a direction. And then the random tile generator, obviously, the game will start off with 2s, and then you combine everything, go on from there. So the random tile will usually start with 2. If it goes up in a direction, then the 4 will get higher, and then you can just move it around throughout the game. So that's something we found and made it much easier. And then obviously we have the grid rotating. That's another function we did. So every time something goes all around, it continues to do its thing. And then we had to create a bunch of other functions featuring the left movement and then the right movement, up and down, besides doing the cases that are at the end of the game itself. Obviously, we called functions on the top, but the game wouldn't actually execute and show up on the screen unless we call it. So we created a whole thing called var game, which is create the grid. And the grid is making the tiles, it's making the background, it's making everything happen for our game, besides our actual draw function, which is going to do everything including the splash screen. So we have the draw grid, all the functionalities of the game, so basically what makes everything work. Then the commands that we used in this portion to make the actual game work weren't taught in the class, but I did add lots of comments describing why we did it, how we did it, because I, as mentioned before, have experience in coding in Java itself, and for our project last year in AP, we had to do a lot of things featuring like math and having to make things like find maximum numbers of an arrays like we did before, but it was on the AP exam, so we were taught all of these things before, and then implementing it into the game made it all the more easier instead of having like negative numbers or anything. So we do have an absolute value right here, because this game, obviously, like make one small mistake in coding and the whole thing can go awry. So that's good there. And then we call the pop matrix, which is for the effects. We had the thing up there that makes it animate, but the actual pop matrix puts the stuff on the screen. Then the mouse clicked function, lots of times we've done that. It's saying that when the current scene is 1, it's going to draw button in our splash screen. Otherwise, this is current scene 2. It's going to put the whole game on there. And then the ending, if a person were to get to 2048, it'll say congratulations, you won the game. Otherwise, they'll say try again, which I did in the other video because I wasn't trying to actually get to the winning score, because the video could be like 40 minutes long. And then lastly, this is for the cases, as mentioned before. We have the case up, which allows everything to move up, case down, left, right, so on and so forth. And the game was done due to the fact that our original idea didn't work, and then this was much more easier about doing all this coding, because obviously the experience before. Also, that we found an easier way to make this game compared to the other game, and that's about it. So this is the video explaining my code and how we did it. All efficient coding, all done during class hours and the help hours when needed. And thank you. This includes the explanation of the code for the second video of this final project.